Hello everyone, welcome to the channel. It is always good to see the projects which enable you to learn a bit more about the intricacies of all of these AI models. Lazy Predict is one such tool which not only helps you build a lot of basic models and how they perform and you can evaluate them, but in my opinion, it also enables you to learn a bit more about classification and regression issues in AI models. When we say classification and regression, classification deals with categories while regression deals with numbers. Classification predicts a categorical output, which could be a class or label from input data. For example, if an email is a spam or not, or if a cancer diagnosis is tumor or not. And regression predicts a continuous numerical output from the input data. For example, predicting house prices, stock prices, or a person's height, things like that. So this lazy predict is a Python library that helps you quickly test and compare multiple machine learning models for classification and regression tasks. It also allows you to train many models at once with minimal coding effort, automatically evaluate and compare their performance and identify the best performing model. We will be installing it locally and then we will see how it works. I also want to thank Mast Compute who are sponsoring this video. If you are looking to rent a GPU on good prices, I will drop the link to their website plus a 50% coupon code on range of GPUs, so please do check them out. Now, to use Lazy Predict, you first prepare your data, you split it into training and testing sets, and then initialize the lazy classifier or lazy regressor. You then fit the model using the fit method, passing in the training and testing data. Lazy Predict creates instances of various classification models. Now, this sounds a bit cryptic, so I think it will be better if I show you what I mean. For that, let me take you to my terminal where I'm running this Ubuntu 22.04. I have one GPU card NVIDIA RTX A6000 with 48 GB of VRAM. But for this one, you don't really need that much GPU, and we will see how much. So let's first create a simple virtual environment with Conda. And then we are going to install some of the prerequisites which include lazy predict with the condas and forge. So I'm just installing lazy predict, scikit-learn, numpy, pandas and skippy. So let's me do that. It is going to take 2 to 3 minutes and everything is installed now. And now let's see lazy predict in action. For that, let me launch my Jupyter notebook, or maybe I'll just quickly go to this directory and then I will just launch my VS Code here and then we will see how the code works in that VS Code environment. So now let's look at this code, how lazy predict is working here. So the step one here is that we are loading the breast cancer dataset from scikit-learn, which is another library, and then it is splitting the data into training, which is xtrain and ytrain, and testing sets, which is xtest and ytest, using the train test split method. And then in the step 2, it is initializing lazy classifier, which is created with optional parameters like verbose is equal to 0 and which suppresses the detailed output, and then we are ignoring the warning to true, and then we are using the default custom matrix. In the step 3, we are fitting multiple models here. Now the fit method is called on the lazy classifier instance, passing in the training and testing data. So behind the scene, what is happening is lazy predicting is creating instances of various classification models from scikit-learn. It is fitting each model to the training data, and then it is evaluating each model's performance on the testing data using default metrics, which is, and I will also shortly show you what those matrices are, which are accuracy, balanced accuracy, ROC, F1 and few others. And then it stores the performance metrics and model instances and then it prints them out. Okay, so now let me quickly run it. So I'm just going to run it from the terminal, and of course you can run it from anywhere you like, and there you go, how quick that is. So let me go up to see what is happening. So now on the first column we have the models, and you don't need to download these models separately. Lazy Predict takes care of importing and using these models from scikit-learn, which is a very popular machine learning library. And then when you install this Lazy Predict, it automatically installs scikit-learn as dependency, by the way. And scikit-learn includes all the model listed here in this Lazy Predict's output. And Lazy Predict is sort of also acting as a wrapper around scikit-learn, which makes it really easy to import models, create instances, fit models, and evaluate performance without requiring any manual import or manual installation. Okay, so now coming back to this output, so these are few of the models. So let's see what these models are, few of them. So first up we have linear models. So we have linear SVC, and then we have some logistic regression CV here, this one I mean. And then also there is a ridge classifier CV here. So for example, this linear SVC uh, supports vector classification or a linear SVM classifier. This logistic regression, it is a linear model for binary classification. Logistic regression CV, it is with cross validation, and it turn logistic regression with cross validation. And this ridge one, for example, this is a ridge classifier with cross validation, and it is a regularized linear classifier with cross validation. I know, a bit hard, but if you're a machine learning engineer, you know what these mean. And these are basically the foundational methods, or sort of a uh, basic things, which if you're learning machine learning, then this is a must. And then there are few ensemble methods here, like a random forest classifier is there, which is an ensemble of decision trees. We have also gradient booster classifier here, which is an ensemble of decision trees and using gradient boosting. And then there are few others, like we have SGD classifier, perceptron, which is a simple linear classifier. This one I'm referring to. We also have passive aggressive classifier, which is an online learning classifier, and it is quite interesting, by the way. And then there are few others, like I would say label propagation, label spreading, quadratic, and then few others. So these models primarily are covering various algorithmic families, including linear models, neural networks, vector machines, ensemble methods, and few others. So now you know what these are. So other than that, I would say that rest of these are the matrices, like I was referring to earlier around accuracy. So accuracy is a proportion of correctly classified instances out of total instances. Balanced accuracy is the average accuracy for each class, which is quite useful for imbalanced data set. Then we have this ROC AUC. So ROC AUC stands for receiver operating characteristic area under curve. This is a measure of model's ability to distinguish between classes ranging from 0 to 1. 0 is random, 1 is perfect. F1 score is quite popular. It is a harmonic mean of precision and recall, and that measures model's accuracy on positive class. And then time taken is a time elapsed in second to train and evaluate each method. So all of these, what they are doing, they are evaluating the model's performance on classification task, especially the accuracy. And ROC is evaluating model's ability to distinguish between classes, and then we have the time taken. So this is how you can just compare and evaluate these methods quite easily. If you would just use scikit-learn, this is a bit of a pain in the back process, but this Lazy Predict has made it quite easy. Now, before I leave you further, let me also give a huge thanks to our sponsors, who are AgentQL. AgentQL is a query language for extracting data from web pages quickly, easily, and at scale. You can use the Python SDK to run your queries in production using Playwright, and use the browser-based debugger for optimizing queries in real time on any web page. AgentQL is a robust alternative to fragile XPath and DOM CSS selectors, as it uses the power of AI to analyze the page structure to find the data you are looking for. Thanks for watching. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel. And if you are already subscribed, then you know what you need to do. Do me a favor and share it among your network, as it helps a lot. Thank you for watching.